Good morning. Um, Today, what we're going to look at is exponential sequences in the sequence material that's in IGCSE. The quadratic and cubic sequences are in core material. Exponential sequences are in extended material. So let me go ahead and share the material that we're going to look at today. Give me a second here. We're going to look at exponential materials. This is for the Year 10 Advanced class, 2024-2025. When we look at exponential sequences, what we're doing here is taking a starting value, which is usually the first term in a sequence, and multiplying it by a constant number. That constant number is called a common ratio. So we start out with a certain value. Our starting value is usually called A. So our starting value is given the symbol A, and the common ratio, the number that we keep multiplying each number by, is given the symbol R. And that's what we use for exponential sequences. Okay, so we get a sequence that looks like this. We have A as our first term, and then we have so we have A as our first term here, and then we are multiplying by a constant number all the time. So A times R gives us AR, then AR times R gives us AR squared. AR squared multiplied by R again gives us AR cubed. So we have something that looks like this. A multiplied by R will give us AR. AR multiplied by R will give us AR squared. AR squared multiplied by R will give us AR cubed, and so forth. And the formula for the term in this sequence is AR to the power n minus 1. Now it's just the R that is to the power n minus 1, not the A. And you can see that formula up here. This is the way we typically write it when we are in IGCSE extended maths. We write the term in the nth position is equal to AR n minus 1. Okay, so let's go ahead and look and see what the assignment is. So most of the questions in our assignment on exponential sequences will ask you to do the following. They'll ask you to find the common ratio. We get the common ratio just by dividing one next term by the other. So we have something that looks like this. R will always equal AR divided by A. So I'm taking this term here and dividing it by the one that comes before it, or it is equal to AR squared divided by this one here. So you can have AR squared over AR, that will also give you R. So that's how we get the common ratio. Once you know A and once you know R, you can find the sequence for the term. That sequence is given as Tn is equal to AR to the power n minus 1. That's the same formula that we have up here. And that's the standard formula for geometric sequences. Now, once you know the formula for the sequence, then it doesn't become very difficult to find the next two terms of the sequence. So what you do here is you're just going to apply the appropriate value for n to get the next two terms of the sequence. Okay, let's look at a couple of questions here. So we know that A is the first term, AR is the second, so AR to the power 1. AR to the power 2 is the third term, AR to the power 3 is the fourth term, and therefore the nth term is AR to the power n minus 1. So let's see if we look at an example question here. We are supposed to find here the nth term and the 10th term of the following sequences. They give us a sequence here. just by looking at this sequence, I can tell that A is equal to 3 because that's the first term in the sequence. And R is going to be 6 divided by 3, which is 2. So I have my A, I have my R, and then I can calculate both the nth term and the 10th term of the sequence. So my first term we said is 3. My common ratio is 6 divided by 3, which is now 2. Or I could have done 12 divided by 6 or 24 divided by 12. Now my nth term, I'm just going to plug the A and the R that I know into the formula. So that's going to be, we said the formula here is Tn equals AR. So Tn equals AR n minus 1. I know that in this particular case, A is 3 and my R is 2. So this would be minus 1. Now, this is not 6 to the power n minus 1. This is 3 times 2 to the power n minus 1. So be careful when you do that. So our 10th term, we now know that n is equal to 10. So what we're going to do, we will multiply that 3 times 2 to the power 10 minus 1, which is 2 to the power 9. Of course, you can do that on the calculator and get 1,536. So that's the 10th term. So that question is complete. With these kinds of questions on exponential sequences, once you're able to find A and you're able to find R, they become much, much easier to do. Okay, let's look at another one here. Again, we're finding the nth term and the 10th term. We have a sequence here that reads 14 minus 20, 10 minus 5. If you have a sequence that is alternating between positive and negative, just like this one is positive 40, minus 20, positive 10, minus 5, then your R is going to be a negative number. That's the clue to show you that you have a negative R. So our first term, of course, is 40. That's the first term on the sequence. Then our common ratio will be minus 20 divided by 40, which of course gives us minus a half, so minus 0.5. So our nth term, we're now essentially getting the formula. We'll put 40 times minus 0.5 to the power n minus 1. So that essentially is, once you know A and you know R, all you're doing is putting them in the appropriate place in the formula. So our 10th term is going to be 40 times minus 0.5 to the power 9. And we should get a negative number, so minus 5 over 64. You can also put it as a decimal if you like, but you can do it also as a fraction. Okay, so that was that particular phrase. As long as you're able to get the formula, you can get any term in that sequence that you like. Now, the other thing that the assignment asks us to do is to find the next 2 terms of the of sequences. So what we're going to do is look at 2 examples here. Here I have a sequence that goes 20, 10, 5, 2.5. I can see that everything is going down by half. So my A, of course, is 20. My first term is 20. My common ratio is 10 divided by 20. So we take the second place divided by the first, and that one would be 0.5. And therefore, our formula is 1. And it's always to the power n minus 1. So once we know that, we know we have 4 terms here. So the first term is 20, the second term is 10, the third term is 5, and the fourth term is 2.5. So we need the 5th term and the 6th term in order to get the next 2 terms. So in this case, n will equal 5. So we're going to have 20 times 0.5 to the power 5 minus 1, which is 4. And once you calculate that, you get 1.25. And We can now get the sixth term in exactly the same way. So 20 times 0.5 to the power 6 minus 1, which is to the power 5. And we get a number that's half of what we got previously, which was 0.625. I'm going to detour here and show you how you can do this on the calculator if you have the class whiz. I'm going to share that now. It's very, very quick if you have the Casio 991 calculator. So what we do here is we go to menu and we go to number 9, which is the table, and it will ask you to put in the function. I know that my A was 20, and I know that my R was 0.5, so 0.5. And I close that, and I raise all of that to the power x minus 1. Now, when we use the calculator, we use x instead of n, but that doesn't change anything. So it's going to ask us, where do you want to start? We always start with n is equal to 1. I want everything up to the sixth term, so I'll make this a 6, and I'm going up by 1. So from 1 to 2, from 2 to 3, and so forth. Okay, and I do this, and I can now see my sequence here. Remember, we had 20, we had 10, we had 5, we had 2.5. Then the next one is 1.25, which was our fifth term, and our sixth term was 0.625. So that's how we know we have done that correctly. All right, let's go back to. All right, so our next question here is we have another sequence here. I'll ask you to pause the video if you can and solve it on your own. And then we will continue once you have had a chance to try this. Okay. Again, we know the first term here is 50. So our A is 50. We get our R by taking minus 12.5 and dividing it by 50. So we have a common ratio of minus 0.25. And then our nth term, we're just going to plug those values into our formula. So Tn is equal to 50 times minus 0.25 to the power n minus 1. Now, once we have this formula, we're able to get the next two terms. So our fourth term, we have 3 terms in our previous sequence. Our fourth term, n will equal 4. So that is going to equal 50 times minus 0.25 to the power 4 minus 1. That will give us 3, and we can calculate that as minus 0.78125. Then we get our fifth term and essentially make the power 4 rather than 3 in our previous one. And now we get a positive number. And when we have a negative R value, we alternate between positive and negative terms. Okay, so that's basically what we're looking at for this exponential sequences. You'll be asked to find the formula, you'll be asked to find the common ratio, and you'll be asked to find the next 2 terms for the sequence. So I wish you the best of luck on the assignment, and that is all for exponential sequences.